We want to look at that if we're given the CDF of a continuous random variable, how can we find its PDF? Now recall, let's do it from here. Recall for a continuous random variable x. So we're writing CRV for short for continuous random variable x. The way you go from CDF to PDF is through differentiation, right? So differentiate. From PDF to CDF, it's through integration. And from CDF to PDF, it's differentiate, right? So the PDF f small f of x is just the derivative of the CDF, which is represented by capital F. So representing the PDF by small f and the CDF by capital F. So what we're going to do is now, for the given CDF, we will differentiate the CDF interval by interval. Right? What do you mean by interval by interval? First, we do it for x is less than 0, for x is greater than 0, less than 6, for x is greater than equal to 6. So we'll differentiate the CDF for each interval in it. We'll differentiate the CDF interval by interval. So we're going to first do for x is less than 0, like the first interval over here. Let's just so we're going to first do it for this x less than 0. And here the CDF value is 0. So let's see, right? So we know the PDF, which is f of small f of x, is going to be the derivative of the CDF, right? And we know the CDF value for x less than 0 is just 0, right? So essentially, we know the fx is equal to 0 for x less than 0. And we know the derivative is 0, or any constant for that matter is just 0. Right, now let's do it for the next interval, which is for x greater than 0, less than 6. Now this interval, so now this is this interval for x between 0 and 6, and this is the CDF value in that interval, right? So, so here also, like we know, the CDF f small of f small f of x is just the derivative of the CDF, and the CDF value in this interval is 1 minus e minus 3x, right? So we have to find the derivative of this. We know fx is equal to 1 minus e minus 3x for x between 0 and 6, right? This is the CDF value here. Right, and if you want to find the derivative of this, this is just going to be turn out to be, so we have e minus 3x. Why? Because let's just recall here quickly. Recall the derivative of e a power x is a e ax, right? So e minus 3x, the derivative is minus 3 times e minus 3x. And here we already have a minus, so minus minus becomes plus. Let's do it for the last interval in the CDF for x greater than equal to 6. Now for x greater than equal to 6, we want to look at this, right? So we have x greater than equal to 6, right? This is the last part of the CDF that we want to, find, right, that we want to differentiate to find the PDF, right? So we know f small f of x, which is a PDF, is equal to the derivative of the CDF, and in this interval, the CDF is defined as 1, right? Because we know, we know, okay, I'm sorry, let me just erase this. So we know that fx is equal to 1 for x greater than equal to 6. Right, and we know the derivative of any constant is the 0, so this is just going to be 0. So if I just write over here in a nutshell, so if I write the overall PDF, then it's just essentially going to be So it's only non-zero for x between 0 and 6. For x less than 0, it's also 0. For x greater than equal to 6, it's also 0. So it's equal to e minus 3x for x between 0 and 6. Like we can see, it's only non-zero in this interval, this, right? It's between 0 and 6. Otherwise, it's 0 for x less than 0 and x greater than equal to 6. 0 otherwise. So this is how we can find the PDF given the CDF. We just differentiate the CDF interval by interval.